This is the whole stream. Welcome to my life. Welcome to the science stream where people get nerdy. All right, here we go. I'll just do my thing then. Thank you, love. Welcome everyone. We're back to our official Tuesday stream, and we're gonna follow through with finishing our first script. I think I'm gonna put my chair up a little too low. This guy got so short, so short. Here we go. All right, y'all. Let's get started. So let me do a recap of what happened last time. We were working on our VMD program. We were scripting a way to figure out we have two residues, and then we chose an arbitrary third residue that was in the center of our protein, aka enzyme. And F1 ATPase is one of the most wonderful proteins, enzymes to work with and to understand, because it's like a technically it's a little motor that works at 99% efficiency in our body, producing energy from ADP, adenosine diphosphates, to create adenosine triphosphates. So it's pretty much reversing the order of us expending energy. When we run, we make adenosine diphosphates by breaking off phosphorus from our triphosphorus chain, and then we store more energy by doing the reverse. So ATP synthase is producing energy for us to store. So that way when we run, we can expend our energy. Now, if you're interested in learning more about ATP synthase, you can YouTube it. You can also read a few free publications that are online, and a lot of the time you can find free publications online. Maybe some of them you have to have access through a paid service provider, such as a community college. One of my favorite things to do to access all these databases is to go to a really well-known community college, enroll in one unit. It would only cost you about $35 per semester, and then you can go into the library and ask them for a computer. So you go and you use your student ID, you log into their computers, and then go to the database. She'll ask the librarian, "Can you show me how to get to this database?" "Oh yeah, no problem." So you go there and you start searching all the technical scientific details of published works from like scientists and like from authors, and a lot of the time when they are published, they are scrutinized by a panel of professionals in the field. So if you're reading English papers, then for them to publish, they would have to submit that to a panel, and they'll all like look into it, read it, and figure out, is this a like working material that we can understand, and it doesn't conflict with other ideas. And if it does conflict, then has it been thoroughly tested for validity? Can this one author change the game for the world by his unique perspective? Yeah, and that's what papers are. A lot of the time, papers have information that conflicts with the other ideas. Like, for example, uh, let's say, what's a good example of this? Hmm, Darwin, social Darwinism. You know, when people figured out that certain animals are growing extinct based off of their geographical location, people didn't understand it. They thought it was completely BS. They thought it wasn't true. But over time, it came to be true that a species thrives in its geographical location. So, one example of how publications have impacted the scientific community. The last thing I wanted to say before we jump into finishing our script for the angular dependency of motion is I wanted to say that you should never be afraid of asking others to explain things to you if you don't understand them yourself. And that's the best way to go about it. It'll save you a lot of time, a lot of heartache, and money, especially money. So I guess we'll go ahead and open up our program. If our music's not too loud, let me turn it down a little bit. Yeah, that should be good. And yeah, let's go ahead and open our program. I'll just minimize my camera a little bit so you can see the workspace and open up our VMD. Here we go. Here's VMD window 1. And occasionally it does freeze on me. And that's okay because I'm running a stream and doing biophysics at the same time. Thankfully, OBS has never crashed on me. That is a good thing. Cool. So let's open up our TK console. Now we can start coding. We'll load TB. Oh, I forgot. Let's see. CD users. Cool. Now we officially coded how to open up our file without having to click anything. And now what I would like to learn is how to change my representations without having to click around in this area here. Well, I think we'll save that for Thursday. Thursday will be a good day to figure out how to code our visual interface. So for now, let's just finish our code, get those angles to be all unique. Our last stream, we figured out how to get our script to work, but the only part that didn't work was changing the frames. We were stuck on frame 1 for all 100 frames, so we were getting 100 of the same angles, and that's not what we want. So let me go ahead and choose backbone on this. And then let me create a couple of representations to show you what we're working with. We'll do backbone, or maybe it's just like residue. Residue was a 644, 660, and 3109. I think that worked. But let's go ahead and change the coloring method to yellow. Yeah, it worked. Look at that. We're getting quick. So now we have these 3 residues that we are trying to figure out the angle of. And we figured out that this first angle is 20 degrees. So we have 1, 2, and then 20. So if this is a line, we can assume that this angle here, from here to the imaginary line, is 20 degrees. Now, our trajectory gives us 100 frames that are all not 20 degrees. And actually, the significant figures, or the decimal places after the after the decimal point, there's like a whole bunch of numbers, and that's your your significant figures. We figured out that all of them are the same, and that cannot be true, because even if you shifted a little bit, maybe like your 100th place or your 1000th place could change significantly, especially when you're going to exact numbers. Yeah, seeing the same number to that exact amount was not showing us actual results. So we want to change our script. And let me show you what the script looked like by first showing you our results. Let me open up. Yep. So this is what we got from our results of our last script output. And you can see that all of them go to this like super exact decimal place 525,849,718,630,134. So now that we know that all of our frames are pointing to the same exact number, we know that our script isn't working correctly, but it's almost there. So what we're going to do is open up our script now and start playing with it and try to fix it. Let's see, that's the one. Here we go. Here's our script. And somewhere here is an error, and we're trying to fix it. So maybe if I should move my camera over to the middle, so yeah, you guys can see the whole thing. Awesome. There we go. Yep. So that's what we're working with. Move this over here. Cool. So we're trying to figure out what the angle of these 3 residues are based off of the picture in our notes. So here, oh, that's the wrong one. Whoops. Let me turn off my stream camera for a second. All right, let me open up that. Okay. Let me open that. Okay, cool. Whoops. There we go. All right. Let me move this over here and close this. Perfect. So now, there we go. We got our notes. Let's open up our notes fully. So there we go. Yeah, so we saw something like this when we selected a series of residues. And these are the residues that we selected to get a picture of this from the whole backbone. And the backbone looks like this. It's like all of the non-yellow stuff. So here we go, and we can move this up a little bit. So yeah, now you can see the whole enzyme here as one piece. And the reason why we chose those yellow positions is because we can scroll down in our notes a little bit, and we see this. We can see kind of like a spiral motion, but those portions are not spinning. It's only the center that spins. So it's kind of like giving us an idea that the structure of the enzyme and the way that the chain of the amino acids are formed to make the protein suggests that it's done in such a way that it gives the electrochemistry and the van der Waals forces and all of the different forces involved, like non-bonded and bonded interactions, such as when two atoms are connected, that's bonded. When two atoms are not connected but they're close to each other, that's a non-bonded interaction. The entire equation for these forces are explained on the VMD tutorial, but there also are many publications that show you like this is like the partial differential equations that like add to the overall forces of this protein. And I don't want to confuse you. Partial differential equations are just a part of a more higher level calculus, and calculus is not hard. Honestly, in my personal opinion, pre-calculus was harder than calculus. Ironically, I don't know why. I don't. To me, learning trigonometric identities was a little trickier than learning how to do derivatives, integrals, and then partial differential equations. So they sound insane, but they're not. They're actually way easier than like trig. So just to think about it in that kind of sense, with all the YouTube videos out there, you're not supposed to know everything. They're just going to test you on certain problems, and they want you to learn those problems. And it's honestly not hard at all. I did great in math. I got A's. In trig, I got maybe a C or a B. So it just like uphill. Back to this problem. So we see that the enzyme has segments of amino acids that are clumped together in a chain, and they form this spiral, beautiful spiral, and it kind of gives the enzyme its energetic energy to move that central gamma shaft in a way and at speed. So right now, this script that we've got written is to characterize just one portion of the enzyme, and then from there we can combine our graph or blah 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 our angles from this script to another script that's going to output our velocities of these exact residues. And then we can pair them together, make a graph that says like the y-axis will be your angles, and then your x-axis will be your speed of each residue or the residue chain. We'll get to the speed of the residues eventually, so let's not worry about it. Let's just finish our script and get those angles. How does that sound? So here we go. Let's see what we can do to make this script work. All right. So what we can do now is this. Let's change something in our script to, it's probably in the while loop. Now, what a while loop is way for our coding to do a whole segment of code and then repeat it for every segment or every frame that you have included. So you can specify, like right here, we're going to use a while code here, and we're going to do it as long as our frames are under 100. So we'll start with 1, and this while loop will keep going and keep writing a new angle to our text file until we hit frame 100, and then it'll end the loop. So that's what this first line means. And as you can see, there's an open bracket here. What are these called? Hey, Natalia, what are those special characters? What are those special characters called that are right above the bracket on the keyboard? It looks like a squiggly line. What are those things called? It's okay. Well, anyways, it's this right here. I forgot what these are called. Let me Google it. It's gonna bug me. All right, let's do that. Curly brackets or braces. That's Wikipedia. Okay, we'll just call curly brackets. That works for me. And if you guys are wondering who am I talking to, we have a friend of mine here on FaceTime. She's auditing our stream, and it's kind of sweet to have someone to ask if you run out of words. She's laughing at me. Anyways, we'll get back to our stream. So yeah, let's see what we're doing wrong in this script that's not giving us a new frame. For example, what I'm thinking is it's right here. Do we have angle degree verify? Like when I use a $sign, that means that I must have defined a function or a character or even a residue by using the command set. Now let's see if we used it more than once. Maybe that's the problem. Angle underscore degree. Nope, I didn't wait, actually. Okay, you know what I think it is? Since we've already set it as our angle degree is 0, then what I'm going to do is I'm going to cut this and put it before FID, which means that it's going to set the angle degree as 0, and then yeah, so maybe the order of angle degree should come before writing it to file. So we'll do that. Actually makes sense to me if you ask me personally. So now we're going to go ahead and load this script and see what happens. Let's see what we got here. Desktop. And then we're going to load our test or speed code number 4, which is the name of our file. Yep. And now let's load it and see what happens. Oh, we got an error. What does that say? Cannot find channel named 26525. Oh, it's our angle that we got. So, Okay, so what we did before was not right. Let's go ahead and revert our changes while we get rid of this new file that we created by uploading our script. So every time we use our script, it's going to upload the same PDB file and also the trajectory for it. And I don't want to crash my BMD program, so I'm going to delete it every time my script doesn't work. So in this case, I can put it back to where it was because it was working before. Well, our error said that cannot find that number. So what we can do is maybe we should get rid of this part here. Oh, I see. Well, here's where we get messy and try a bunch of different things. So maybe before we make an adjustment to our script that actually kind of works, we're going to save it as speed code 5. We'll just keep going in a series of numbers until we get something working. And I think I like to do that every stream, is start a new script or copy it over to a new name. So even if I make a mistake, I can go back to my old one. And let's see what we can do to make this work. Let's script proteins. Yay. All right. All right. So now if you're curious as to what the dot product is, it's a part of the math that we were speaking about earlier, and it's a simple process, honestly. It involves matrix math, and it's not difficult at all. It's actually one of the easiest things, and you probably have already done it in elementary school at one point, but it is something that it's very lightly touched on, like just multiply over dot product. So to create a new from like a set of 4 numbers, you can create 2 numbers, and then from a set of 3 and so forth. You could just YouTube a video, what is dot product, and you'll learn that way. Now let's see. I'm gonna be quiet while we listen to music, and we can figure out how to get this script to work. If anyone has questions, don't be shy to ask. Hmm. Oh, I have to tell you guys something. So whenever you see a hashtag or the dollar or the number sign, I'm sorry, that means that anything on this line is not to be used in the code. So a lot of times people use the hashtag to explain what the next line is going to do. So that's what a hashtag is. Exclude that line practically. Something that we learned in the last stream was that VMD version 1.9.4, and I think they named it alpha or something like that, it doesn't work. I tried it, it doesn't work. It doesn't let you do these normal commands. So in our last stream, we downgraded to 1.9.3, and it works. Everything works flawlessly. If anyone pushes you to like update or upgrade your like Windows software, I would wait a little bit. You never know how many bugs there are, honestly. And from the looks of it, they're constantly improving their softwares at both Microsoft and also at the University of Illinois Urbana-Champaign. So in this specific moment, I think alpha should not be used just because it couldn't even do simple things. Let's see what we can do here. So where's my while? Here's my while. And then we have an if in there. And then we have an else. And we have a close bracket, a close curly brace or curly bracket. Somewhere in here, there's an error. And what I'm going to do is this. I'm going to do this. I'm going to do two separate puts. I'm going to do a puts $ angle degree, and then increase angle degree. Then I can just write the whole thing to my FID. Now what is FID? So at the very first line, I put set FID. FID is like a random acronym that I just named myself. So it's like me naming what the line's gonna do. So what that line is that ignoring the command set, because now you know what that means. It means to create a new abbreviation for a line or like just a one line thing. So now FID stands for I'm going to open this output1.dat, and then I'm going to write to it with the W. And that's all in a bracket. And that's going to tell people, or at least my computer, to if output1.dat does not exist currently, then this line is going to actually it's going to create it. It's going to create the output1.dat and then write to it. So only if it doesn't exist, it will create it. If it does exist already, then what it's going to do is just open the file and then rewrite whatever I want to it. And then at the very end of the script, I said closed FID, which means close the file because we're done with it. So let's try this script. Maybe this one will work. So what I did was I separated the puts command. I did puts angle degree to set the angle degree to 0 only if the magnitude maybe I can do this. Put that in this. Let's see. So a double bracket. Maybe that'll hold it all in together. Yeah, maybe this will work. But then also what I did was I separated the puts command. So now well, you know what? What I'm going to do is get rid of that extra bracket. We're going to got a mosquito in here. All right. Cool. So now we only have one edit. We've only adjusted our script one way, so we know if we messed up that way, we can try the other one. Yeah. So yeah, let's just do that. I changed puts FID angle degree to puts angle degree first. Increase angle degree. If maybe not that yet. Maybe even not angle degree. Yeah, let's just do that. Let's forget about the angle degree, because what I think happened is that if I ran that command angle degree, then it will set the angle degree to 0. So then any other degrees that follow it will just be the first degree or the first frame. So I think maybe I caught it. Let's run it. Save. And then load. So it's loading the script and see what happens. Do we have an error? Yes, we have an error. It says here that we could not find the channel or find channel named 26 degrees. Oh, that's interesting. it's actually not updating to our new script because you can see this. We got rid of that part and I see what's going on. If you were to put like this, hold on. Did I not remove it? I thought I removed it. Oh, you know what happened? I loaded the old script speed code 4, not 5. So what we're going to do is redo this, but instead upload the right file. um yeah, let me delete the new molecule. And now let's actually load the right the right script. 5. Oh, and I forgot to rename it. So maybe I should save as, and then I can do like all files and then just delete the text. So now the TCL extension will be recognized by our VMD program. So save, and now let's test it out and see what happens. There it is. .tcl. You want the .tcl if you're going to run a script. Open. Do we have an error? Cross my fingers. Oh, what happened here? Okay, let's see. Did I get an actual working output? If so, our script is done. Um, it looks like it's still writing to it, which is not. Oh, actually, it didn't work. What happened instead is it outputted. What did it do here? It looks like instead of putting the angle of the degrees of each frame, it just suggested that it should be named as something new. So if I'm not mistaken, I can actually open one of these and see if it changed. So to open up a file, I think it's grub 98 file to D85 A680. No, it's not gonna work. Um, how do you do that? It's been a while, so I'm gonna ask how to open a text file in CMD. And what is that called? It's called. No, it's like so simple too. I forgot. Um, what is it? Let's go to Windows and see what they say. Perhaps is Linux. Let's ask it to do it. Okay. Whoops. In Linux, I think Linux would be better. There we go. Terminal. Yeah. There we go. So it would be cat. How did I not know that? I have a cat. So let's do that again. So the code to open up a text file is cat. Did not work. Hmm. Perhaps it only works in Linux. So okay. Okay, let's okay. Okay. Let's see how to open a text file in VMD TCL. Oh, here it is. So let's read it. Maybe I should just type open. Oh, Whoops. Open. That's an N. Yeah, it doesn't. Somehow it doesn't work. So back to the drawing board. What could it be? Hmm. All right. Let's see what we got. All right. Let's see what's going down. Oh yeah. First, I gotta delete that extra molecule because we don't need that to crash our program after every script. And let's see what we can do. Maybe. So what I did was I pretty much consolidated all 3 lines of code to one because what's going on is I'm selecting 3 residues and actually I'm selecting I'm actually selecting 3 atoms. So I chose 3 residues, sure, but I'm also choosing 1 atom in each residue. Like name CA means choose the alpha carbon in the residue glycine, which has a res ID 169 because there's so many different glycines in this protein. If I don't specify the residue ID number of 169, it could be any of those glycines. So you need 3 things to specify which residue, which version of the residue, or which area of the enzyme the residue exists in, and then also which atom in the residue you want to select. So since our angle is dependent on one of these, I'm sorry, dependent on 3 atoms and not 3 residues, we're going to get a much more precise number for our angles. So let's see what we can do to get this to work. Now, the problem is we're getting the same angle for all 100 frames, and that should not be happening. So let's take a look. Second. Okay, I'm gonna jump to the bathroom for one moment. I'll be right back. All right, here we go. Back to it. So let's see what we can do to fix this wonderful script. Okay, so what I'm going to do, I'm going to, okay, I'm going to ask AI, what am I doing wrong? So this is my script, and it's only outputting 100 different lines of the same angle. What can I do to fix it? Semicolon, paste, and enter. So it's suggesting to it's suggesting one fix. It's suggesting that I put inside of the loop the selections. So this is what I'm gonna do. I'm gonna cut this. I'm gonna press enter here and put that here. So I'm just gonna move one line over, and it says that it suggests putting all the selections inside the loop so that it recognizes the coordinates and the changes while it's in the frame. While it's in the loop, that's what I meant. So let's save and make sure we deleted the old version. Yes, we did. And let's re-upload it. So going to 5, speed code 5. Hopefully we don't get a error code, but it's gonna happen. I know it. Yeah, it gave me an error selection thing. So now it's giving me this improper method. So, maybe I should just separate them. Let's do this, this, and then we'll just copy this over this. Okay. So let's try this. Maybe this will fix it. And then delete the new molecule and try again. Cool. So I did save this. Let's go ahead and load it now. New let's load our new script changes. Oh, let's see if we got something. There is no error code, so that's a good sign. But the same thing happened before where we didn't get any outputs, but all of the outputs were here. Okay, so let me do this. So I'm going to do this. I'm going to tell AI that instead of the angles populating in output 1.dat, this occurred in TK console. Okay. Let's see. The output you're seeing in the TK console, such as file, suggests that there is a problem with how you're attempting to write the file. It looks like the file handle is not properly opening the file for writing. Hmm. Okay, so it added a section that I don't currently have in there. So this is what I'm gonna do. I'm just gonna copy that section and put it there. And it's this section here. And then we're going to save it. We're going to delete our secondary molecule that we just uploaded and try it again. I'm sure I saved it. Yeah, double checking. And then load our new edited script. Oh, it's missing a close brace. So that means let's do this. Oh, right. Forgot the close curly bracket. Done. Now it should work. Let's see if there was an... Nope, everything is fine. Let's just add that exit brace and load the newly edited code. Okay, let's see what happens. Oh, it did the same thing again. But perhaps our output.dat got adjusted as well, maybe? Nope. Wait a second. Yeah, it's just still empty. So if I type, yep, there's nothing there. Don't save. Yeah, it's not working. So let me tell it. That didn't fix the problem. The cool thing about asking AI for help coding is that for every tab you open up in AI, all of the material you were talking about stays in that tab. So you can just refer to something you mentioned earlier, or that the website mentioned to you. So every tab is unique to its own like AI, like information galaxy. So like whatever you talk to, or you set the subject for every tab. So if you're talking about how to fix your code, it'll stay on that topic as long as you're, vague enough. So that's a way to do it. Now let's see. Oh, okay. So now it's telling me to add a change. And the change is going to be, instead of putting just puts FID, it's going to ask me to flush, which means to write all of the data immediately. Yeah. So let's go ahead and leave that here. We'll do those two changes. We'll just add the angle degree back because that worked for the first part at least, and then flush FID. And we'll try it. Let's save this, delete our secondary molecule. Cool. And all right, cool. Now let's redo this script, double check we saved it, and let's load it. Okay, now we've got an output.dat. Hopefully it works. No, it worked. Oh my gosh. Our first script worked. Look at that. Holy moly. So it looks like the problem was it wasn't writing. Well, there's a few problems. First, the BMD wasn't working. And holy moly, that worked. Okay, let me go back to OBS. We did it, guys. We did our first successful script together. Wow. All right. This publication will be pumped out soon through two universities that I work with. And yeah, my yeah, this is gonna be great. I'm gonna pump this out as soon as we get our second script down, get our velocities, and yay, we got our first working script. Woo! I wish I could like code something so that there's like fireworks going on, but just use your imagination. Fireworks everywhere. We got our first working script. Amazing. Um, yeah, that's so great. Holy moly, that's great. So what the problem was that when um when we first used VMD, we used the wrong version of VMD, and some of the commands that are super basic, like moving and naming things, didn't work. Number two, we have found that after updating VMD, now our script was working with the name section, and we were now trying to figure out how to create a loop that can determine properly the angles of three arbitrary points in our molecule, and the arbitrary points happen to be three atoms, and one would be kind of somewhat in the center where the gamma shaft is. The second point would be on that wonderful spiral that we have. Let's pull it up again. So we have one point in the middle, and then one right here and one right here. Now you can see this is straight. It goes down but not towards the center. So we got this angle, 1, 2, 3. And now we've got that for all frames scripted. Now that took some time, maybe like 5-6 hours, maybe even more. I think I did spend about 10 hours on this. And I'm sending this script over to my advisor. He's going to absolutely adore it. But yeah, now I'm actually not going to just send the script, but I'm going to send everything. I'm going to send the graphs, I'm going to send the scripting, I'm going to send all of that stuff. And who knows, maybe in like a few months I'll have another publication in the biophysical society. So it'll be great. Let's go. Next script. All right, let's go ahead and put a couple emojis here. I'm just gonna use common emojis like a Pikachu. Yay, we finished our first script. Done deal. Okay. Not nice. So what I'm gonna do is I'm gonna put that that working script in my notes. So go ahead and put today's date, 10/17/2023. We research results. Well, let's do code successfully made of errors. VMD 1.9.4 didn't work properly. Downgraded to 1.9.3. Number 2 is the vector package was not installed in VMD, so we used dot product as simply as possible without conflicts. And what was the last error? There was one more error. Okay. So, yep. Let's go ahead and yay, we did it. We did it. Our first script together, all in VMD, and we did it. And we were successful, and we can keep going. Now we're going to keep scripting till there's like 1,000 scripts. Well, let's just take baby steps. Now, let's not think too far ahead. We might just like trip on the way. Okay, since we did our first script, I'm going to take a break and we'll be back. Face here. Cool. All right, I'll be right back. All right, we're back. And it looks like we've finished our first script ever. It's a big day for us. We'll include these findings on our Sunday stream and have that for the weekly I guess publication. We'll just like publish our works on Sunday. Well, anyways, the files that I have for my for the research that I do are not this simple. We have like for a much more advanced side where those files I can't obviously use them for stream because they're patented and copyrighted and whatnot. But the simple stuff definitely not. So for the more advanced stuff, I'm going to be doing my code for that, sending it out for a much bigger file, much more frames. We're talking about hundreds of thousands of frames rather than just 100 frames. So I'm using this script on my major research project, and that's going to be published in a paper. For now, we're just going to do the simple stuff together, not get too infringement wise. We're not gonna infringe on any of those patents and copyrights. I can't use those files. But for this stream, yeah, we could just do the basic stuff. Can't get too infringe as a joke, of course. All right, so let's get serious and start making our code for our velocity. Now we know that from residue 1 to residue 2 on the arm. Let's go back to that picture. So we have this arm. So one of these, and then a center point like here. But if we just look at this, it'll be a lot easier to look at. So there's a center point we chose, and then 2 arms. So let's pull up VND to show you that. And here it is. So that picture is technically 1, 2, and 3. And you kind of see that it deviates from the center. 1, 2, and 3. There's an angle here. So now what we're going to do is figure out, since we know the angle of it compared to the center shaft for all the frames, not just one, we're going to do this. We're going to set arm 1 and 2 as a vector. So a vector is when you connect 2 points with a line. We're going to treat this whole line as one piece. So we'll just create a line from here to here and treat it as one entire arm, or here's an analogy. We'll just treat this as a stick. And this stick has a speed. So we're going to get the speed of the stick for all 100 frames. And what that means is that for frame 1, we'll know that it has an angle between here, but we're now going to determine its speed. And if we determine that there is a correlation between this speed to that angle to actual real life data, which I cannot show you here because it's all copyrighted, but for my own personal research that gets published in journals, scientific journals, we're going to get more advanced and we're going to compare it to the real life stuff. So there's a whole bunch of real life stuff that I have to compare it to. I can't talk about those details here, but you can just imagine that if I figure out that this velocity correlates with the speed, and it works by comparing it to real life enzymes such as F1 ATPase, then I can actually script using machine learning a way to determine the speed and the physical phenomenon that go on with this enzyme in real life. And then that paper will be most likely my second publication. So yeah, we'll just get started and make another script. So here we go. Let me open up my notepad. Oh my gosh, look at those numbers. That's great. Like we got like 16, 17 degrees, 15 degrees, got like 20 degrees here. I'm going backwards, by the way. Anyways, what's the highest degree? It looks like 25, oh, 26. 26. Um, that's great. It's a very stable fluctuation. Thankfully, one part of our script says that if it kind of like sets our magnitude to 0 if it deviates in a way to mess our math up. So this section here is really nice. Dividing by 0 gives you an error. It just gives you an error. It doesn't. It means that your math isn't working out. Okay, so and if you have 0 divided by a number, you obviously get 0. So if 0 is on the numerator, you get 0. 0 in the denominator, you get it error pretty much. So let's get into our second script. I'm excited. Let's do it. So save this as angle script script 1. And we'll do all files and then put dot TCL. Done. Cool. So that's good. Cool. Now let's go ahead and figure it out. So we'll just copy some stuff from our first error. So we'll take this. Cool. Just copy that stuff over. And this too. Yeah, we'll just copy all that stuff. And we'll create a while. Yeah, the while loop's in there. Yep. And now we're going to do this. We're going to copy this and paste it here. And we'll do a close bracket. And then we don't need this anymore because we're not getting angle degrees. And from here, we'll just start from this section here. So how are we going to determine the velocity of that? So what we're going to do is create a mathematical equation that TCL language can understand to set these 2 points as so it looks like we don't even need our phenylalanine in the entire script, so we'll just delete that. We'll delete this, and we should be good to go. Yeah, we just need the points between 153 and 169. So just these, and we can ignore this. So what I'm going to do is go into BMD and turn off 3109. Done. Now it's gone. Now we can go ahead and start. So we're going to do this. Well, I'll just play it for you and show you what happens to it in its natural state. And I'm going to press play, and you'll see it wiggle. Oh, I didn't upload that yet. So let me go ahead and load. Perhaps not that. Let's see. Right click, load data into molecule, and then we'll choose our trajectory, which should be, where is it? You know what? I'm just going to type it out. Done. And then load. Cool. Now you can kind of see what I'm working with here. So let's just put it on loop. You kind of see that it's moving. And yeah, so we're trying to figure out how fast it moves. Maybe if I like slowed it down a little bit, you can kind of see it in like frame by frame action. That would be better. So, yep. Now we've got our visual interpretation of what we're trying to do is determine how fast these two or how fast this connection is moving per frame, and then we can ultimately determine that every frame is 0.1 nanometers, and No, I'm sorry, nanoseconds. My apologies, nanoseconds. Nanoseconds. We're dealing with time here, so the distance would be roughly about 100 angstroms, or 10 to the negative 10 meters. So I'm sorry, one to 1 times 10 to the negative 10. That's tens, 9 zeros, and then one after the. So it's decimal place, 9 zeros, and then one. That's how many. That's how small an angstrom is. So when I say 100 angstroms, then you could do 10 to the negative 8. I'm sorry, well, I don't know why I keep saying 10. It's 1 times 10 to the negative 8. That's the distance here. If I can guesstimate, knowing that it's like roughly 20 angstroms from atom to atom. So I know I'm wrong. That's just a rough estimate. So giving you a spatial idea of like how small these things are. Very, very small on the meter scale. Okay, so let's go ahead and start scripting. So let's see what we got going on. I don't know what I did with my water. Looks like I'm gonna go get some water, guys. Um, I'll be right back. Gonna get some water. All right, so back to it. I got my giant jug of water. Pour myself some water. All right. I hope to inspire everyone to get involved in science because it's so much fun. Literally, so much fun. I don't think, you could watch like Family Guy every night and it's funny. It's really funny. And actually, Family Guy for me personally, actually, it's a really, really great way to spend some time if you're stressed out because you just need to laugh every now and then, maybe every day. Now, science is a little different. Whatever you do can ultimately change the world for better. Even if it's just in a small way, like whoever invented the period or the comma, thank you. Those small things make a big difference because we can, speak to people and know where our sentences end. I should drink. Oh, I was quite dehydrated. The first script took a lot out of me. My cat's really like curious at what's going on because our house is being remodeled and everything's like in shambles. So my cat's like, "Why can't I go downstairs?" I'm like, "Because you can't." Vomit. Make sure he doesn't go anywhere. Hold on. All right, my cats aren't messing around. They're good. Okay, here we go. Get started. Dang, I keep forgetting something. You know what? It's been a long day. I've been on my feet for like 13 hours. I apologize. I keep walking away. I forgot one thing. I gotta go grab it. It's only gonna take me 10 seconds. All right, let's get coding. All right, here we go. Let's get started. Um, I don't think this is gonna work because I remember from the last script, Vex sub didn't work. Okay. Yeah, this is not gonna work. Um, all right. Here we go. Um, okay. Okay. Let's try this. Oops. Yeah, I think that was it. Okay. Let's try this. And okay. We're good. Yeah, this should work. And then we could do this as out speed1.dat and save. Cool. So now what I'm going to do is I'm going to delete frames. Oops. Oops, that was my bad. How do I undo that? You know what? We'll just delete the molecule and start fresh. Cool. So, whoops. Uh, Load our angle or speed. No, that wasn't speed. This angle script. So it's gonna be at the top. Angle script 1, load. See what error we get. Yep, it says pos2 is not an array. So I'll go ahead and copy this. I got this error. Okay, so we have an error. Let me pause it. Delete molecule. Let's fix our code. Oops. Cool. Yeah, let's keep going. Here we go. Error on the wall. Whoops. Whoops. So we're just gonna copy all of our errors and go back to AI and see what it does. Oh, got to close this. There we go. Try our new updated script. All right, let's try this. Copy. Okay, so I think what happened was I put an extra curly bracket here, and that's what caused the error. So we're gonna try this. Let's delete the molecule, save the updated script, and reload. Okay, so it says here. So it's interesting. Maybe we should restart VMD. Let's restart it. Gonna restart VMD and see if that fixes it. Yep. Okay, let's try this. Interesting. Gonna work again. Hmm. Okay, let's try it again. Okay, I got the same error. Hmm. Oh, VMD crashed. Interesting. Hmm. All right. So, what are we going to do? What are we going to do? All right. Let's figure out how to fix this script. I'm gonna try like one more thing, and then we'll raid someone, and we'll try again on Thursday. Let's see what is going to fix our script, because what error I'm getting is saying that the subtraction right here is not subtracting numbers, which is not true. So let me try something. I think, uh, is there any way script can exclude full index and still work? Oh, so the index command is used to access elements of a list in TCL and is essential for extracting specific elements from a list. In your script, Lindex is used to extract the individual elements of the position vectors in your list, which is a crucial part of your velocity calculation. So, what can I do? Well, let's see. So if Lindex is needed, then oh, this is going to take quite some thinking to figure it out. Maybe. Interesting. Okay, what am I gonna do? Hmm. I don't know. Maybe it's a good time to call it quits and try again on Thursday. I'm gonna have to think about this because I'm having issues getting actual XY, and well, actually just X and Y and Z coordinates from this while loop. So let's go ahead and raid someone. I'll save this. Yep. Hey, save our notes. Close that. Our DMD program. Okay, cool. So thank you guys for watching, and let's figure out who we're gonna raid. Well, we figured out our first script. Major kudos to us. And let's see what we can do. Who are we gonna raid? Where's the chat? Okay, let's see who's live. Oh, I know who. I know who we're gonna raid. There is, cool. Yeah, we'll go ahead and do that then.